So talking about thyroid hormone synthesis and storage, let's start. Here we go. This is the thyroid follicular cells, and the first step is iodide uptake. From here the iodide is trapped into the follicular cells, and the trapped follicular iodide passes through a transporter, and this transporter is known as pendrin, right? And through this pendrin the iodide is transported across the membrane, right? And here it undergo oxidation. Yes, iron undergoes oxidation to produce iodine, and there is one enzymes through the help of which it undergoes oxidation, and it's known as thyroid peroxidase. What it is? Thyroid peroxidase, right? And here we in our thyroid follicular cells we have our thyroglobulin, and it is made up of tyrosine amino acid, right? So there are some tyrosine residues of thyroglobulin which come and combine with the iodine, right? So now this iodine combined with the tyrosine residue of thyroglobulin to form MIT, right? MIT and DIT. Now what is MIT? MIT stands for monoiodo. MIT stands for monoiodotyrosine. MIT stands for monoiodotyrosine, and DIT stands for diiodotyrosine, right? So basically it is known as T1, and Di2 known as T2. So we have talked till now two steps, and that is this is the iodide uptake into the follicular cells. Next one we talked about the oxidation and this we can say that it's the iodination or organification. Now coming to the next step, it's coupling, right? So coupling, next step is coupling. Now 2-DIT means that is diiodotyrosine, it combines, or 2T2 combines to form one T4 molecules. As I have earlier mentioned that the T4 is known as the thyroxine. T4 is known as the thyroxine, which is a thyroid hormone, right? And now one MIT, that is T1 plus 1-DIT, which is the T2, and it combines and it forms T3, right? Normally T4 is more than T3. Normally T4 is produced more in our body than T3. But if there is iodine deficiency, then what will be the change? Any guesses? If there is iodine deficiency in the iodine molecule, it means T3 will be more than the T4. Understood? And now coming to the next step, it's the storage and release. It's the storage and release, right? It's the storage and release. So as I have earlier mentioned that the thyroglobulin molecule along with MIT and DIT, it couples, thyroglobulin molecules couples, there will be some MIT, there will be some DIT, but 2-DIT combines to form T4, and 1 MIT and 2-DIT will form T3. Now this remains as a colloid, and by endocytosis process, this colloid undergoes our follicular cells, and there is presence of lysosomes. So by the help of lysosomal enzymes, the T3 and T4 are released in the follicular cells. MIT as well as DIT are also released. This MIT and DIT undergoes deiodination process. It will lose the iodine molecules right, iodide ions, and this T3 and T4 are released into blood, and so it is known as the final step is known as peripheral conversion of T4 to T3. Basically in our body T4 is more produced, but the active hormone or the more potent one is T3. So to work to control our basal metabolic rate, है ना, the T4 is converted into T3, है ना, and this process is known as deiodination, and it takes place with the help of enzyme iodothyronine deiodinase. Thank you guys. Please subscribe for part 2. Please share and subscribe. Thank you for today guys. Hope you enjoy the videos.